Hello everyone, welcome to another video of class 10 general mathematics, and today we're going to start exercise 6.4. In our previous video we have seen how to solve the theorem that will be involved in this exercise, and today we're going to start and do some of the sums of this exercise. So first of all, let us start off with question number 1 of exercise 6.4. So this is 6.4, question number 1. What is the question? If you have your book by your side, take it out because it will be helpful for you. So let triangle ABC be similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square. We have two triangles ABC and DEF. Let us draw a rough diagram. We have ABC and we have triangle DEF. We have two triangles which are similar to one another, and the area. So let us write what is given. It is given the triangle ABC is similar to triangle DEF, and we have two more things. Area of triangle ABC is equal to 64 centimeter square, and area of triangle DEF is equal to 121 centimeter square. Also they have given that EF, the value of EF is 15.4 centimeters. Okay, what do we have to find? We have to find BC. So EF is given and its corresponding side, which is BC, we have to find that. So what do we know from the theorem? So we know, if you have seen the video, if not seen the video of theorem 6.6, go back, check the video and then come back. Otherwise you will not understand what theorem we are using here. So what we know from here is that area of triangle ABC by area of triangle DEF, ratio of the areas of two similar triangles, is equal to the square of the ratios of their corresponding sides. So that means BC by EF whole square. That's what we can use. So now area of triangle ABC is given, it is 64, and that of DEF is 121, and we have BC's value we have to find out, and EF is given as 15.4. this will be squared. So that means we can write BC squared is equal to, by side change, it will be 15, it will be 15.4 squared into 64 is 8 squared, 121 is 11 squared. So that means BC will be equal to the square root of 15.4 squared into 8 squared by 11 squared, which means it will be 15.4 into 8 by 11. If we cancel, we will get 1.4, which will give us BC is equal to 112, right? Okay, 11.2 centimeters. So this is the value of BC. We have used the simple theorem 6.6, and from there we can get this idea that BC will be equal to 11.2 centimeters. Very simple, just use the theorem. Perfect example to understand how to use a theorem. Easiest way. So done, this one is done. Let's move on to the next sum, and we are going to do number 3. So let's see how to do number 3. So question number 3, what do we have here? So there is a figure given. It looks like a trapezium, but they have not mentioned it as a trapezium. What they have said is there are two triangles on the same base. Okay, so triangle ABC and triangle DBC are two triangles on the same base BC. If AD intersects BC at O, show that. Okay, so we have triangle ABC here, ABC, and triangle DBC. They are both on the same base BC and they intersect at O. AD and BC intersect at O. So we have to show. So what do we have to show? So first of all, we can write what is given. Triangle ABC and triangle DBC are on the same base. BC. We have to show that area of triangle ABC by area of triangle DBC is equal to AO by DO. So for this we have to do one construction. What is the construction? We will draw two perpendiculars, one from A to BC and one from D to BC. Okay, so two perpendiculars will be drawn. Let's give them some names. Suppose this is E and let this be F. Okay, so E and F, AE and DF. So AE is perpendicular to BC and DF is perpendicular to BC are drawn. Okay, so we have two perpendiculars drawn on the base BC. So what do we have to do now? So let's start the proof. Okay, so as we have drawn two perpendiculars, we are going to use it first hand. So area of a triangle, we know the formula is half into base into height. So what we can do here, we can write area of triangle ABC by area of triangle DBC will be equal to, for area of ABC we have half into base into height, for this DBC also we will have half into base into height. So for both the triangles the base is common, that is BC. For triangle ABC the height is this one that we have drawn here, AE, and for DBC it is DF. So we will write AE and here we will write DF. So BC and half will cancel, so it will become AE by DF. So let us take this one as equation number 1. Okay, now let us move ahead, and what we can do now, we will actually take two triangles. Which two triangles? We are going to select these two, this triangle here and this triangle here. Okay, that means triangle AOE and triangle DOF. From triangle AOE and DOF, what do we have? We have here two perpendiculars, so two angles are equal, and look at these two angles here, these two are vertically opposite angles. So that means these two triangles can be called similar triangles by angle postulate, right? So we are going to take these two triangles from triangle AOE and triangle DOF. What do we have? We have angle AOE equal to angle DOF because they are both vertically opposite angles, and we are going to have AEO equal to angle DFO, which are both equal to 90 degrees, right? That's what we have here. We have these two as 90 degrees and these two as vertically opposite. So by angle postulate we can say that the two triangles are similar. Therefore triangle AOE will be similar to triangle DOF by which postulate? Obviously by angle postulate. Done. Now we have two triangles similar. Now if we have two triangles similar, we know that their corresponding sides are equal. So what we can write, corresponding sides are not equal, corresponding sides are proportional. So what do we have here? From triangle AOE and DOF, we do have AE by DF, right? Let's go back to the diagram. From here we can write AE by DF is equal to AO by DO. Obviously, see, AE by DF is equal to AO by DO. Let's take this as number 2. Now if we compare the two, equation 1 and equation 2, we can replace this part, this AE by DF by AO by DO, right? So from 1 and 2 we can write area of triangle ABC by area of triangle DBC is equal to AO by DO. Hence we have proved it. I hope you understand what we have done here, what we have tried to accomplish in this sum. Not very complicated, it is actually pretty easy. So you need to keep things in mind and you need to have a good perspective of what we are trying to choose here, which triangles we are trying to choose. If we know which triangles to choose, which way to proceed, you'll be easily able to solve this. Okay, so we are done with number 3. We are going to do two more sums today, number 6 and number 7. So let's move ahead to number 6 and see how to solve them. Question number 6. So what do we have? Prove that the ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding medians. Okay, so we have two triangles. Suppose triangle ABC and triangle DEF, and we have their medians as well. So the lines joining to the midpoint. So this is D and suppose this is EF, suppose G. Okay, so ABC and DEF are two similar triangles, and AD and GF are their DG are their medians. So we have to prove that the ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding medians. So given, or let's not write given, let's write let triangle ABC be similar to triangle DEF, AD and DG be their medians. Okay, done. So what do we have to show or to prove? That area of triangle ABC by area of triangle DEF will be equal to AD by DG whole square. This is what we have to prove. So how do we move ahead with this? So what will be the first step? Now see, triangle ABC and triangle DEF are two similar triangles. So if two triangles are similar, we know from our theorem, we know that. So we will write that since triangle ABC is similar to triangle DEF, so therefore area of triangle ABC by area of triangle DEF will be equal to AB by DE squared equal to BC by EF squared is equal to AC by DF squared. Also, we can write that AB by BC is equal to DE by FG or EF, sorry. So also we can write AB by DE is equal to BC by EF. So in case of BC by EF, obviously we can multiply the numerator and denominator by half, right? Now how will this help us? Half of BC. See, since D is the midpoint of AB, then half of BC can be written as BD and half of EF can be written as EG, right? I hope you agree. Half of AC can be written as BD, BC can be written as BD, and half of EF can be written as EG because D and G are the midpoints of the two bases. So we can write this as BD and this as EG. Okay, done. So we have AB by DE is equal to BD by EG. Further, we also have angle B equal to angle E. Obviously, since triangle ABC and DEF are similar, their corresponding angles will be equal. So we can write angle B is equal to angle E, corresponding parts of similar triangle CPST. Okay, so angle B is equal to angle E. Now we are going to use all these data into taking from triangle. We are going to take these two triangles. If you look into the diagram carefully, we are going to take triangle ABD and triangle DEG, ABD and DEG, and what do we get from here? Let's see. From triangle, sorry, ABE and triangle DFG or DEG, sorry, DEG, what do we have? We have AB by DC. From here we can write, we can take this as number 1, we can take this as number 2. We will let AB by DE is equal to BD by EG, and also angle B equal to angle E. This is from number 2. So what does this show us? That two sides are proportional and one angle is equal. So if you look into the diagram here, we have said that AB by DE is equal to BD by EG. That means two sides are proportional. Along with it, the angle that lies between the two sides are equal. So it is like side angle side postulate. So by this postulate, we can obviously say the triangle ABE is similar to triangle DEG by side angle side postulate. Okay, now what is the use of writing these two triangles as similar? What do we need to prove? We need to prove that triangle ABC and DEF areas, ratio of the area is equal to AD by DG whole square. Now what have we shown here? In this part of the sum, what have we shown? We have shown that the ratio of the areas is equal to AB by DE, BC by EF, AC by DF, right? Now since these two triangles, this one and this one are equal, what we can tell or what we can write is that AB by DE is equal to AD by DG, and AD and DG are what? AD and DG are the medians. So what we can write is therefore AB by DE is equal to AG by DG. Number 3. Thus what we have is area of triangle ABC by area of triangle DEF. Obviously it is AB by DE whole square. In place of AB by DE we can write AG by DG whole square, and that is what we had to prove. I'm sorry, not AG by DG, I think I've written it wrong. It is not AG by DG, it is AE by DG. It will be okay, AE by DG. So that is all about this sum. Okay, so first of all what we did, we tried to prove that the two triangles ABE and DEG, ABE and DEG here, these two ABE and DEG, these two triangles are similar. Once we could do that, we could write that AB by DG, okay, let's use this part. We could write that AB by DG is equal to AD by DF. Okay, it is AD, right? Let me see where I went wrong, what I wrote wrong. Wait, this is not ABE. I think I wrote the name of the triangle wrong. It should not be ABE, it should be ABD. This should be D. Okay, this place I got something wrong. From triangle ABD and DEG, let's go back to the diagram. ABD and we have DEG. So it is ABD DEG. ABD DEG, yes. So it will be, yeah, here also I got it wrong. Okay, a few places that went wrong. Let's do the corrections. You will also understand how to do it correctly then. Means the mistakes that you can go through. Okay, so AB by DE, where did I get AB by DE? Yeah, AB by DE is equal to BC by, yeah, this is correct. This part is correct. Number 1 is correct. So from triangle ABD and triangle DEG, we have AB by DE. Yeah, I was right actually. AB by DE is equal to BD by EG. Yes. So that's how you prove it. Okay, I was actually right at the end. So, okay, so this is how you solve question number 6. Let's move on to the next one. We have last sum for the day. That is question number 7. So how do we do question number 7? Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonals. So we have a square. So this is how the diagram is going to pan out. We have a square. This does not look like a square. Okay. We have a square, and they have said that if you draw a triangle, an equilateral triangle, on one of the sides of a square. So suppose this is an equilateral triangle on the side of the square, and suppose you draw another equilateral triangle on the diagonal of the square. Okay, so suppose this one, this may be suppose A, B, C, D, E, F. Okay, so triangle ABC and triangle CDE, these are the two triangles. The right triangle ABC is on the base, on the side of the square, and triangle CDE is on the diagonal of the square. So what we have to show is that the area of the triangle on the formed on the side of the square is half the area of the triangle formed on the diagonal. So for this, to make it a very easy sum, let's consider the sides of the squares be of length A. So let A be the length of the sides of the squares. Okay, pretty simple, straightforward. Now what we will do is, from this diagram, see, since ABC is an equilateral triangle, if this is A, this will also be A and this will also be A. So since ABC, triangle ABC is equilateral, therefore area of triangle ABC is equal to what? Root 3 by 4 into side square. What is the side? The side is A. So root 3 by 4 into A square. This is number 1. Done. Now, if we have to apply the same thing onto the other triangle CDE, we need to find this diagonal, right? The length of the diagonal, because the length of this diagonal will be equal to CD and also ED. So how to find the length of the diagonal? Look at triangle CFE. This triangle CFE. This is a right angle triangle, and here EC is the perpendicular hypotenuse. So using Pythagoras theorem, we can write so here from triangle EFC, what do we have? CE square is equal to EF square plus CF square. So what is CE? CE is our diagonal, that is the perpendicular hypotenuse. EF is actually A square and CF is also A square. So it is root over twice A square. So ultimately CE is equal to root 2 into A square. So now that we have found CE as root 2 into A, this is also going to be root 2 into A and this is also going to be root 2 into A. So now we can find the, okay, this is not square. Okay. So now that we know the three sides of the equilateral triangle, we can find the area of the triangle. So what will be the area of the triangle? So therefore area of triangle CDE is equal to root 3 by 4 into side square. So in this case, what is the side? The side is root 2A whole square. So it is root 2 by 4 to twice A square. Let's take this as number 2. Now let us divide 1 by 2 so that we can find the value. So we have area of triangle ABC by area of triangle CDE is equal to root 3 by 4 A square, and it is root 3 by 4 twice a square. So everything will cancel out and it will stay as area of triangle CDE. If we change this 2, side change of 2 will give us twice of area of triangle ABC, and that's what we had to prove, that the area of the triangle formed on the diagonal is twice the area of the triangle formed on the side. And that's how you prove it. Just take one of the sides as A, that all the sides will become A. Find the length of the diagonal. So then you will get the sides of both the triangles. Once you know the sides of the equilateral triangle, obviously you can use the formula root 3 by 4 into side square for both the triangles. Once you do that, it becomes pretty easy for you to solve. So that's all we have for today's video. 4 sums we have done. We have 4 more sums. If you can understand these sums, those sums can be done by you quite easily. If you face any problem, make sure you comment down in the comment section and I'll be there to help you out. So thank you everyone for watching, and until next time, cheers.